Hello everyone. In this lesson, we are going to learn another technique in differentiating a function or relation, and that is what we call implicit differentiation. So dito, malalaman natin kung papaano at kailan gagamitin itong technique na to. Now, in our previous lessons, we have learned how to differentiate functions that are written explicitly. When we say explicitly written, those are functions of the form y equal to f of x. So we have y in terms of x's. Those are what we call explicit functions. Okay? So those are explicit functions. So functions that are written explicitly. For example, we have y equal to x. We know that dy over dx will be equal to 1 because the derivative of y is dy over dx or y prime, and the derivative of x is 1, right? But we have already seen functions or relations that are not written explicitly. For example, we have x squared plus y squared equal to 9. So this is an equation of a circle, and this is not written explicitly. So if that's the case, medyo mahihirapan tayong mag-differentiate sa equation na to. So one remedy would be changing the given equation of the form y equal to f of x. So in that case, we will solve for y in terms of x in this case. So solving for y in terms of x, we will have y squared equal to 9 minus x squared, right? If we will just add negative x squared both sides, we will get this one. Then since we are looking for y, so we need to get rid of this square here. So we will extract the square root of both sides. Extracting the square root of both sides, we will have y equal to plus minus square root of 9 minus x squared. So we have already written the given equation of the form y equal to f of x. However, as you can see here, we have two functions involved, plus or minus. So in that case, medyo malilito tayo kung anong function ang dapat gamitin. So in that case, hindi natin maa-apply agad-agad yung mga differentiation rules na alam natin. Okay? At dito ngayon papasok si implicit differentiation. Implicit differentiation is a process of getting the derivative of implicit functions or relation. Ano ba yung mga implicit functions or relation? Those are functions or relation that are not written explicitly, like this one. So this is now an implicit relation. X squared plus y squared equal to 9. Okay? So in that case, applying the implicit differentiation, makukuha na natin yung derivative niya. Pero papaano ba siya gagawin? Now, differentiating quantities involving only the variable x with respect to x is not a problem because the derivative of x, we know that is equal to 1. Like we have x here, so naging 1 siya dito sa derivative. Also, if we have x squared, we know the derivative of x squared will be 2x, right? So if we only have the variable x, then that is not a problem. Okay? But if we have other variable, then we will now, because that variable is a differentiable function now of x. So if that's the case, we will now apply the chain rule. So if the derivative of x squared is 2x, then the derivative of y squared now will be 2y times the derivative of the inner function. And our inner function now is cy. So we have the derivative of y with respect to x. So therefore, we will now differentiate y, yung mga other variables aside from x, okay, with respect to x. So if that's the case, we will take the derivative of the given term as a whole, like we have y squared, so the derivative will be 2y, and always multiply it by its derivative with respect to x. So we have 2y times the derivative of y with respect to x. So we have dy over dx. So in this case, if we have x squared plus y squared equal to 9, then applying the implicit differentiation, we will now have the derivative of x squared will be 2x. The derivative of y squared will be 2y times the derivative of y with respect to x. So dy over dx equal to the derivative of 9 is 0, right? So in this case, we will now solve for dy over dx since we are looking for the derivative. So solving for dy over dx, we will add both sides negative 2x. So we will have 2y dy over dx equal to negative 2x. Okay? Now, para si dy over dx na lang yung matira sa left side, we will divide both sides by 2y, right? In that case, we will have dy over dx is equal to negative, we can cancel out to x over y. So this is now the derivative of x squared plus y squared equal to 9. And that is negative x over 9, y. So from that, we have differentiated the given equation using implicit differentiation. Okay? Para mas maintindihan, let's consider another example. Suppose we have this one. So medyo maraming terms na yung nakikita natin dito. We will differentiate y cubed plus 4y squared plus 3x squared y plus 2x plus 10 equal to 0. So we will differentiate each term. Okay? So in this case, let's differentiate first y cubed. So this is the solution now. So the derivative of y cubed will be 3y squared using the power rule. And since we have y, we will multiply it by its derivative with respect to x. So we have 3y squared dy over dx. Always multiply the derivative of y by dy over dy over dx. Okay? Plus the derivative of 4y squared, that is 8y, right, times the derivative of y with respect to x. Plus, in this case, we have 3x squared y. So we will apply here the product rule. Okay? Product rule, this will be our u, this will be our v. Again, let's recall the derivative of u times b will be u dv plus v du. So in this case, our u is 3x squared, our v is y. So we will have u dv, so u is 3x squared there, times the derivative of v. What is the derivative of y? That is dy over dx. Okay? Plus we have v du. So our v is y. Then let's multiply it by the derivative of u, which is 3x squared. So the derivative of 3x squared is just 6x. So wala na siyang dy over dx since 3x squared yung kinuhaan natin ng derivative. Okay? So we have this one. Plus, the derivative of 2x is just 2. Then derivative of 10 is 0. So we have equal to derivative of 0 is still 0. So we have that one. Okay, then let's simplify. We will have 3y squared dy over dx plus 8y dy over dx plus, let's multiply these terms here. So we have 3x squared dy over dx plus we have 6xy plus 2 equal to 0. So we have that one. And since we just need to solve for dy over dx. So lahat ng terms na may dy over dx, ilagay natin sa left-hand side of the equation, and the rest, you put it in the right-hand side of the equation. So yung matitira ay ito lang mga terms na ito, yung mga dy over dx. And itong dalawang to, ilagay niyo yan sa right-hand side of the equation. So we will now have 3y squared dy over dx plus 8y dy over dx plus 3x squared dy over dx equal to, from positive 6xy, magiging negative 6xy siya. Then from positive 2, magiging negative 2 siya. Okay? Then after that, you can factor out dy over dx here. So we have dy over dx times, so yung matitira will be 3y squared plus 8y plus 3x squared equal to negative 6xy minus 2. Para dy over dx na lang yung matira, we will divide it by this term here, right? So divide it by 3y squared plus 8y plus 3x squared, magiging dy over dx na lang yung matitira sa left-hand side, and we have negative 6xy minus 2 all over 3y squared plus 8y plus 3x squared. And this is now our final answer. Okay? So that is by using the implicit differentiation. Okay? So I hope naintindihan siya. Another one. Basta yung tatandaan natin, if we are differentiating y, palaging meron siyang times dy over dx. Always remember that one. Another example. Suppose we have x plus y cubed equal to e raised to dx, e raised to xy to the power of 4. So we will now differentiate each term. Using implicit differentiation, we will have the derivative of x will be 1. The derivative of y cubed is 3y squared. Dy over dx, since y yung involved, then equal to the derivative of e raised to xy to the power of 4. Again, in this case, we will use chain rule. Okay? Since we only know the derivative of e raised to x is e raised to x. So, si x naging xy to the power of 4 siya. So, yung inner function natin ay si x raised to the power of 4. Ito yung inner function natin. Okay? So, using the chain rule now, the derivative of e raised to xy to the power of 4, so we will differentiate the outer function as a whole. So, we will have e raised to x y to the power of 4. So, leave the inner function as is lang siya. Then, we will multiply it by the derivative of the inner function, which is xy to the power of 4 with respect to x. So, again here, we applied the chain rule. Then after that, here, we will apply the product rule as well as the implicit differentiation since meron tayong y involved here. So from that, we will now have 1 plus 3y squared dy over dx equal to e raised to xy to the power of 4 times, using the product rule, this is your u, si x, and your v will be y to the power of 4. So u dv plus v du, magiging u is x, times the derivative of y to the power of 4, and that is 4 um, 4y to the power of 3 times dy over dx. So again, here we have applied implicit differentiation. So x, so u times the derivative of v, which is y to the power of 4. Derivative of y to the power of 4 is 4y cubed dy over dx plus we have v So we have y to the power of 4 times the derivative of x is 1. So we have 1. Okay? So from that, we will now have 1 plus 3y squared dy over dx equal to, we will distribute this one. So we will have 4xy cubed times this. So we have 4xy cubed e raised to xy to the power of 4 dy over dx. So I just multiplied e raised to xy to the power of 4 times x times 4y cubed dy over dx. So pinagsama ko lang lahat. Okay? Plus, you distribute this one and to y to the power of 4. So we have y to the power of 4 e raised to x y to the power of 4. Then after that, ipagsama nyo lahat yung may dy over dx. So as you can see, itong dalawang terms ang may dy over dx. So itong term na to, ilalagay natin sa left-hand side at si 1 ilalagay natin sa right-hand side. So we will have 3y squared dy over dx minus, so magiging minus yan, 4xy to the power of 3 e raised to xy to the power of 4 dy over dx equal to y to the power of 4 e raised to xy to the power of 4 minus 1. Then after that, we will factor out dy over dx. So yung matitira will be 3y squared minus 4xy cubed e raised to xy to the power of 4 equal to y to the power of 4 e raised to xy to the power of 4 minus 1. Then solving for dy over dx, we will just divide both sides by this term. So yung mangyayari, we will have dy over dx equal to y to the power of 4 e raised to xy to the power of 4 minus 1 all over 3y squared minus 4xy cubed e raised to xy to the power of 4. And that's it. This will be our final answer. Okay? So from that, we have differentiated this complicated equation here na madali lang using implicit differentiation. So again, reminder lang, if you are differentiating y, always multiply it by dy over dx. Okay? If we are going to use implicit differentiation. I hope nakuha nyo yon. Okay? Now, because of implicit differentiation, we have come up with the formulas for the derivatives of the other transcendental functions. So what are the formulas? So we have here, let u be a differentiable function of x, then the derivative of b to the power of u. So this is an exponential function. The other form of the exponential function, kasi yung alam natin is the natural exponential function, si e raised to the power of x, right? So dito, we have b. So b is any real number. Okay? So from that, we have b to the power of u. So ito yung derivative niya. So we have b to the power of u times ln of b times the derivative of u, the inner function. Okay? We have the derivative of ln u. We have 1 over u times du over dx. So you differentiate again the inner function, whatever that inner function is. We have the derivative of log of u with the base b. We have this formula. So this is for logarithmic functions. Okay? And then we have itong may mga negative 1. These are what we call the inverse trigonometric functions. So ito lahat ng nandito, mga inverse trigonometric functions. Okay? So we have 6 formulas for this one. So just memorize the formulas because we will apply these formulas mamaya. Okay? So let's have examples for this one. Yan. Differentiate ln of 3xy equal to y plus x to the power of 5. So here, we will apply implicit differentiation at yung derivatives ng other transcendental functions. So we have here for ln. So our u is 3xy. So ito yung u natin, yung inner function. Okay? So as what the formula states kanina, the derivative of um, ln of u is equal to 1 over u du over dx. Always remember this one. So in this case, our u is 3xy. So from that, the derivative of ln 3xy will be 1 over 3xy since our u here is 3xy times the derivative of u with respect to x. So we will have derivative of 3xy. Actually, we are applying the chain rule here. And implicit differentiation is just a chain rule also. Okay, so we have chain rule here. Okay, equal to the derivative of y, implicit differentiation, that is dy over dx, right? Plus derivative of x to the power of 5 will be 5x to the power of 4. Then, here we will apply the product rule. Okay? So, product rule yan with implicit differentiation kasi merong y involved. So, we will have 1 over 3xy times product rule. So, our u is 3x, our v is y. So, u dv plus v du, u is 3x, so 3x times the derivative of v. So, derivative of y will be dy over dx, right? Plus y, or our v is y, times derivative of u is 3x. So, the derivative of 3x is 3. So, we have y times 3 equal to, you copy dy over dx plus 5x to the power of 4. Okay? Then let's simplify. So let's distribute this one here and here. So we will have 3x, 1 over 3xy times 3x times dy over dx magiging 3x over 3xy dy over dx siya. Okay? Plus, we have y times 3, that is 3y times this one. So we will have 3y over 3xy. Okay, equal to, you copy, dy over dx plus 5x to the power of 4. Then let's simplify. 3x, 3x, so mawawala yan. So what's left is 1 over y dy over dx plus 3y mawawala. So 1 over x na lang yung matitira equal to dy over dx plus 5x to the power of 4. Then after that, ipagsama lahat yung may dy over dx. So we have this term and this term here. So ilipat natin itong isa sa left-hand side at itong 1 over x sa right-hand side. So we will have 1 over y dy over dx. At yung dy over dx sa kabila, so we have minus dy over dx equal to si 5x to the power of 4 minus 1 over x. Ayan. Then let's factor out dy over dx here. So we have 1 over y minus 1 equal to 5x to the power of 4 minus 1 over x. So from that, to solve for dy over dx, we will divide both sides by 1 over y minus 1. So yung mangyayari, we have dy over dx equal to 5x to the power of 4 minus 1 over x all over 1 over y minus 1. Okay? So this can be your final answer. Okay? Or if you want to simplify it further, so you can combine this and this one, and you do the division. So you will get the other form. So kayo nang bahala doon. Alam niyo na kung paano siya gagawin. Okay? So we will now have this answer. Now, for the last example, we have here to differentiate cosine of y squared minus 3 equal to the tangent inverse of x cubed plus ln y. So as you can see here, we will be applying the implicit differentiation. So recall that the derivative of um, cosine u is just equal to negative sine u du over dx. So therefore here, since our u is y squared minus 3, we will apply the chain rule. Okay, so mag-chain rule tayo dito. And our inner function is itong y squared minus 3. So for the solution, applying the chain rule, we will have the derivative of cosine is negative sine. So we have negative sine of our u. U is y squared minus 3 times the derivative of the inner function. And our inner function is y squared minus 3. So we will differentiate this one with respect to x. So we have y squared minus 3. Then equal to the derivative of tangent inverse. If you can still recall from our formula kanina, the derivative of tangent inverse of u is just equal to 1 over 1 plus u square du over dx. So our u here is x cubed. Okay, so therefore, we will have 1 over 1 plus our u is x cubed to the power of 2 because we have u squared here. Then, multiply it by the derivative of the inner function, and our inner function is x cubed, so we have the derivative of x cubed with respect to x, plus we have ln y, the derivative of ln u is just equal to 1 over u du over dx from our formula kanina. And our u here is y, so we will have 1 over u is y, then derivative of our inner function, and that is y. So we have the derivative of y with respect to x. Then after that, let us now simplify. So we will have negative sine of y squared minus 3 times the derivative of y squared using implicit differentiation or the chain rule. We will have 2y dy over dx, right? Derivative of negative 3 is 0, so ito lang yung matitira. Then equal to 1 over 1 plus x cubed to the power of 2 is just x to the power of 6. Then the derivative of x cubed is just 3x squared, right? Plus 1 over y. Derivative of y with respect to x is just dy over dx. Okay? Then let's simplify further. So negative sine of y squared minus 3 times 2y dy over dx. So let us just multiply. Ipagtatabi lang natin sila. Now, in this case, wag niyong i-multiply si y squared minus 3 kay 2y. Because y squared minus 3 is the argument. Siya yung angle. Okay? So, we will multiply 2y to the whole function, the sine function here. So, we will just um, multiply 2y to negative sine. So, that will become negative 2y sine of y squared minus 3. So, ipagtatabi nyo lang sila. Then, we have dy over dx. Then, this is equal to, this will become 3x squared over 1 plus x to the power of 6. Then, we have 1 over y dy over dx. Next, we will isolate all terms with dy over dx sa left-hand side of the equation. So, itong 1 over y dy over dx, ilalagay natin sa kabila. So, that will become negative of 2y sine of y squared minus 3 dy over dx. Then, from positive, magiging negative 1 over y dy over dx siya. Then this is equal to 3x squared over 1 plus x to the power of 6. And from that, we can now solve for dy over dx. So first, we will factor out dy over dx. So we will have dy over dx times 2y sine of y squared minus 3. This is negative. Then minus 1 over y equal to 3x squared over 1 plus x to the power of 6. And from that, to solve for dy over dx, we will just divide both sides by this factor here. So what will happen? We will have dy over dx equal to 3x squared all over 1 plus x to the power of 6. Then all over this is negative 2y sine of y squared minus 3 minus 1 over y. And you can have this one as your final answer. Okay? And that ends our discussion on implicit differentiation. I hope meron tayong natutunan and thank you for watching.